All right, so basically after every talk, I'm saying that I'll never do this again, but somehow I did. So kind of like a continuation of a previous talk, and the reason I'm saying this never again part is I thought I would be talking about something more deep divey, but during the creation of the talk, I kind of thought that if that's supposed to be like a story, then I should probably talk about a little more about the controllers themselves rather than diving straight into the use case. So in Kubernetes, because I often mix Go and Kubernetes as well, and I hope you don't mind too much. But what is controller? In general, a controller in Kubernetes, or the Kubernetes itself is composed of a metadata storage, which is etc, and a bunch of controllers, which are like endless loop processes that observe the state and change if needed, right? So the controller is like a non-terminating loop that monitors the system, and based on declarative data in the metadata store, it tries to put the state of the cluster into the state that was requested. And you will often see that the people when talk about controllers, they often talk about operators as well. And I will, for the rest of the talk, use term controller because I'm lazy. But there is a slight difference that's kind of syntactic. If you see operator in the context of Kubernetes, there's basically a specialized controller that acts on custom resource definitions, and that is the only difference. So a controller is a more abstract concept, which is a general and endless loop that does something on a cluster. And when you start acting on custom resource definitions and you tie custom resource definitions into a picture, that's when you are talking about operator. And custom resource definitions kind of outside of the scope of this talk, but it's like basically your version of horizontal pod autoscaler or whatever spec you are submitting to Kubernetes, and you're absolutely free to define your own. And how this definition looks like this is by no means a very custom, but it's a proper definition of a resource, right? So we have a cron job controller that's running in Kubernetes, and it's a very Pursman autoscaler. The reason this is autoscaler is the original talk was supposed to be on autoscalers and custom autoscalers and the fun we can have with doing them. And I started thinking of a generic non-NDA version of the scaler that I can show, and I was thinking, okay, we have horizontal autoscaler and it's doing its job, but it's based on CPU and memory, and of course there are like custom metric scalers as well. But what about like a I don't know, Black Friday autoscaler, right? And I thought maybe I will write a Black Friday autoscaler that's scaling just before the Black Friday and like hard coded and scales down like after Cyber Monday. And then I was thinking about this and I thought like that's a poor example because I can do this with a cron job. But in general, like you submit this and there is a process that's observing those documents being submitted to Kubernetes and they act on them, right? And that's pretty much what a controller does. And a last piece of theory, what else controllers can do? So that they're good for cluster observation. They are basically constantly monitoring and observing the state of resources. Like every resource you have in Kubernetes, you can observe constantly and act on any change to it, right? They're very good on enforcing desired state. That's basically the bottom line of Kubernetes. You have like replica set or stateful set. Like the whole point of existing for them is to keep your pods in a state that you want them to be, right? The number of pods or whatever. Resource limit enforcement. So you have stuff like resource quota, or there used to be a pod disruption budget, for example. You can have defined schedule. That's basically a cron job. You can have event processing, which is basically every life cycle event that comes from Kubernetes you can act on. So you don't only like observe the state of the objects themselves, but you really act on, or you can act on every life cycle event, right? You can monitor the health of the entire cluster. It's not only namespace, but you can also act on cluster life cycles. And of course, you can roll out and roll back and do whole bunch of crazy stuff. So to start with custom controllers, the most, I mean, you can write everything from scratch. That's also possible. But it's a lot of boilerplate. Like it's tedious. There's also another way that I will show later on. But the most basic example, like if you want to do an example for a talk, that's controller runtime. It's part of SIGs. It's basically developed by Google, Red Hat, and some other guys. And it's a framework for developing controllers. So basically, they give you, like, you have a process, your application. They give you a manager that kind of embeds API server client and controller and webhooks, which are also sort of outside of the scope. They're tied to the custom resource definition themselves. And you can have, they implement the entire loop of receiving events and filtering them out and acting on them. And like a different view of this diagram is more or less like this. The yellow ones are the pieces that you will interact with from the framework as part of writing your own controller. But what you're really required to provide is this reconciler, and that's pretty much the entire picture. And I will just kind of get deeper into each piece of the picture, but or maybe I should. So the manager. What is the manager? This is a quote from the docs. A package manager is required to create controllers, provide shared dependencies, and etc. etc. Right. So it's just managing the controller. The most interesting part of it is, except for like managing the life cycles and all that, it also manages leader election. So each controller in a deployment, they figure out which is like active, and the manager handles this for us. And the manager also manages health endpoint and metric server and pprof and some other like generic stuff around your application. Then we got a builder. So after we create a manager, we go back, or the next step is to use builder. And we didn't really like use it explicitly. Like we don't do anything with the builder except for using a builder pattern to create a controller. And this is again from the docs. The very reason for having a controller is to wrap creation of controller, but also everything around it. The ecosystem is a little more complex, and I will just show this in a sec when we will talk about controller itself. It provides, or it exposes some funny methods for owns and watches. So when you use builder, you basically need to provide two things. First of all is which resources are you interested in, and there is a difference sort of in how you can be interested in those resources. So for is used to indicate a resource that you're interested in and you will act on. So like you will actually do changes to the resource. And for every controller, then there can be only one resource, or the controller can only act on one type of the resource. And you can have owns. So you're interested in resources that are technically owned by the resource that you declared previously in terms of owner ref in Kubernetes. So like think replica set and pods, right? Pods are owned by replica set, so you can say you're like, and we'll actually do this, or I'll show how it's done on a very generic example. We can say for replica set but owns pods. Watches is lower level, where you basically define your own event handler, so your own way to speak to Kubernetes API server. And when you define like what resources you're interested in, you say complete, and you provide your own implementation of a reconcile interface. And when it's done, the builder takes all of that and creates a whole backend for you, which is a watch loop that talks to the API server, receives events. There's a queue between like receivers, and I'll probably show that in a sec when we will talk about controller. But so the builder creates this entire backend for you. And the controller. The controller basically is a wrapper around this work queue that takes information from API server from different sources. Each of the each source is defined by these 4 owns and watches. It puts messages on work queue. There is another processing loop that takes events from the queue. It filters them based on your preferences, and then it wraps it in a request struct that is passed to your reconciler interface. And reconciler is returning a result of your action. The result can be of 3 types, basically. So you can either create a empty result or whatever with nil. That's success. You can return an error. In this case, the framework will retry on this reconciliation, and that happens more often than not. Sometimes resources changed, and in a process of changing the results in an error, it says that you need to reapply and stuff, and at some point it works. And you can request to retry yourself, like in case of a controller that itself is a loop of sorts, maybe a something like cron job So if it knows the cron jobs that were submitted, it can sleep until like the next cron job is, and then there is no change in the system itself. Like there is no action from Kubernetes API, no live, no event, but the controller itself can say like wake me up after whatever, and it will go again, wake up, and can process actions. And that's and the first 2 points. The reconciler doesn't know which event triggered it. Whether this was retry or create or update, like you're obligated to check it yourself. Like this reconcile function needs to check for the context when it was waken up. And yeah, like a technical note, I will be using a struct in the example, but it's just an interface, so you can pass a function as well. A reason for choosing a struct for me often is like how many calls to the API server I do. If I really do calls to the API, I tend to use a struct and cache the client and just use it. And that's I should probably I should probably do this now. So as an example, let me show you. I won't be trying to pretend I'm using NeoVim all the time. So we have a main loop, as I said. Yeah, there should be it was like presenter. There was something like that. But anyway, so let's just
more.
What?
There is presentation mode in IntelliJ, I believe.
Yeah, but where?
Appearances. The top. In the view.
View. Appearance. Yeah, that should be here. Enter presentation. Okay. So we have a. So we create a manager. That's the very first step. I'm passing here some options to restrict it to the namespace. Otherwise, it will be cluster level. Then we are using this builder, and you can see it's the first step is to say which manager controls the or will be controlling the controller. You specify for which resources you want to be responsible for. You have this own's method that says which other resources you want to watch, and then you complete it with passing your own reconciler struct or function. Here's like here is the function where, as I said, I'm caching the client just because like there's a couple calls to the API server, and then you start, and that's all you really need to do. As I said in the beginning, it's a middle ground between writing it yourself and using different solutions. I probably wouldn't use that approach for something that uses CRD. CRD for me is like this line in the sand where I'm saying like I'm really using builder. And what else you do is you have this method reconcile. And what reconcile does is for request, I'm getting a resource because all I got was a namespace name. Then I'm listing all pods for my replica set. So I'm casting this to replica set, and then I'm getting the template labels just as the replica set controller is doing. And I'm really doing a documentation, the stuff that I took straight up from controller runtime documentation, which is annotating replica set with the number of pods. And I call an update, and that's it. Logging reconciles as successful. And how this works is really really simple. So I have no pods. I have now tell me out. I'm not a this was one B. What was the damn. So we have a example example replica set. What was the airbag? So we have an example access definition, which is like pretty much boilerplate, but you need to remember about this. This is one of the things you need to remember about when you're doing this yourself. And I will in a second say the alternatives and controller. And here we have controller. So I'm specifying the service account, and I'm specifying deployment with my controller. And how does it work? So I apply -f example, and if I get RSK so as you see, there is no annotations, and then I do OK. So I'm doing the airbag first. Let me rebuild it just to make sure. Why it takes so long? And that's what you get for not vendoring dependencies, I guess. So, well, let me stop this, and I hope I have a pretty decent version out there. So apply -f controller, and what happens is that our controller started, and it first got events for all the replica sets that were there, and you see my very verbose log message reconcile successful with rs namespace pod count, and it says okay, the pod count is 1, right? So when I check the describer as GoCracow, now you can see it got a new label, pod count equals 1. And that's pretty much
Scale replica set to 2.
sure. Okay, edit. Where are you? And yep, we got some errors. Operation couldn't be fulfilled because object has been modified, and then we got a bunch of updates because of replica set, but also because of pods. Because for the foreign owns, each of them gets the event, and when we describe it as pod count too. And that's pretty much the simplest stuff I could show in a limited time. And like, why, right? Why? Because operators or controllers are a great alternative for anything else we do with clusters. Like we usually, and Splunk is no exception, we tend to lean heavily on like pipelines side, and we have like those complex Helm charts and complex Quebec configurations, and we try to keep our state in sync, sort of in like infrastructure as a code way, but very imperative rather than well, it's sort of declarative, but you can do a lot of stuff. So first of all, you can exchange pipelines for operators, and a good example of that I actually done at some point is, let's say you have your service and you have API gateway, right? And in order to expose your service, you'll also need to configure API gateway. And you can try different approaches. Usually it looks like API gateway has its own repo. So first you go to API gateway repo and you make an MR to expose, to add code to expose the service. And then you go and you expose your own service, and it's a bit of a mess. And you could have like an operator, right? That you would just submit your service with additional resource definition, or even make it look for the services or the service resources. And the operator, let's say in specified namespace, whenever you make a change or create a new service, it could look at this and automatically talk to API gateway and configure it, right? I said autoscaler before. Autoscalers are like horizontal pod autoscaler is great, but CPU and memory are probably the worst indicators of where you need to scale in an IO-bound world. Like if you have, I don't know, jobs that process videos, that's okay. Like, you know, creating thumbnails or anything like CPU memory, or don't kill me, Java applications. But like if you're IO bound, probably the better indicator for scaling is a depth of a queue or depth of a backlog, or like whatever else you're doing, right? And you could try to correlate, and that's what usually people do, like correlate CPU usage with the backlog size, and try to come up with like thresholds to scale, which is sometimes working, but usually when it works, it usually works at the cost of cost. Like you need to over provision usually to handle this, and if you want to keep your cost tight, that's probably not what you want to do. So there are some custom autoscalers. I've been personally using one from Zalando. There is also a Prometheus adapter that so the autoscalers usually work the way you provide those metrics to metrics API server. But you could do an operator that talks directly to to I don't know, AWS, for example, or directly to Azure, or directly to whatever, and scales based on metrics from the cloud provider themselves. And reason for this might be speed. So when you have CloudWatch that has like 1 minute delay in metrics, and then you have some CloudWatch exporters that export your CloudWatch metrics to Prometheus, and then you use autoscaling based on Prometheus on top of horizontal pod autoscaler's delay, because horizontal pod autoscaler has a fixed algorithm for how it scales, then it's not really reacting fast enough. Like maybe you don't care, but maybe some of your applications really care how fast you can react to the incoming messages, right? This algorithm is another reason. Sometimes you want to be more flexible than this algorithm. It's pretty rigid in a sense how it operates, and sometimes it's not good. What else? There's probably like a ton of reasons. I don't think I can come up with from the top of my head. I've probably forgotten some.
One question regarding that, because you can use KEDA with custom scaler, which can do basically anything.
Which KEDA? You can. You can. Yes. Oh, I had another reason to use operators, dev environments. So in environments where maybe you have KEDA, but in order to properly test out KEDA, you would have to migrate to stage, prod, whatever, and you want to quickly prototype in dev. You might want to have your own namespace operators, for example. But yes, KEDA, I forgot about KEDA, but indeed KEDA is pretty good. Oh, and there is another thing that actually works with KEDA, by the way. I've seen. I'm kind of afraid to judge, but I've seen autoscalers based on AI, and I've seen in particular one that actually works with KEDA. That's why you reminded me of it. That is making this decision based on historical data pushed through some AI model, and that's like AI autoscaler, which okay. It probably works. They made a startup out of it, so maybe it's working. And the other thing I alluded to previously, so of course you can write everything from scratch, just talking to API server, that's cool. You can use controller runtime, but you can use KubeBuilder, which is actually built on top of controller runtime. Controller runtime is a sub-project of KubeBuilder, and KubeBuilder is really like a CLI and ton of generators around controller runtime that allow you to first of all quickly generate code within the controller. So they add all this stuff for like for owns, like which resources you wanna watch, and just let you do the actual reconcile method, but also handle a lot of stuff around your deployment. So this airbag handled out automatically. The KubeBuilder is adding some cute annotations, which permissions you need, and then when generating, it automatically generates appropriate roles and role bindings and all that stuff. Certificates, when you start making more complex interaction with Kubernetes API, generates self-signed certificates, handle this for you. Like there's some reasons you maybe not necessarily want to do everything your own, and then they make a lot of like helpers to help you with the simple annoying stuff. And that's, and when I said previously also CRDs are pretty much for me a go no-go decision whether to use KubeBuilder or just maybe use controller runtime alone. So every time I go to CRDs, I'm implementing any CRDs, I'm just like, let's go KubeBuilder. And that's it.